Now we get to solving rational equations. All right. And the way I like to introduce this topic is not by starting with rational equations, but instead starting with a linear equation that has fractions, because the steps are very similar. So I like to say that solving an equation that has fractions is like an analogy for solving the more complicated looking rational equations that you're going to have to do in this homework. So, uh, like I always say, doing this on paper, watching me work this out on paper, I think makes more sense to you guys. I don't know if that's true or not. It's just something I believe. But I'm going to write this down 1 over 2 plus x over 3 equals 1 plus 5 over 6. Okay, and we're going to solve the equation by following the steps that are on the screen, but really we're going to solve the equation by clearing the fractions. Okay, that's the most important thing that we can do here. Clear the fractions so that eventually we get an equation that does not have any fractions, because that's going to be easier for us to manage. It's going to be easier for us to solve. Okay, so let's dive in. Okay, can you guys see this all right?
Yes.
Awesome. Okay. I think that the first thing that you should be able to do here is count the number of terms. Okay. So the first thing is count the number of terms, because it otherwise, like if you can't differentiate the different terms in an equation, then everything turns to mush when you're looking at it, right? So can anybody tell me how many terms do you think are in this equation?
Two.
Where do you think the two terms are? What is the first term?
On the like I'm counting from the left side of the equation.
Okay, so over here where these guys are?
Yes.
So you're saying that this is one whole term and this is another term over here.
Oh, well, if we count on both ends, it'll be four.
Okay, there we go. That's what I want to see. So when I'm saying count the number of terms in the equation, I'm definitely talking about the whole thing. You definitely identified that there are two sides of the equation, but like 1/2 is your first term. X over 3 is your next term. The number 1 is your third term, and then 5 over 6 is your fourth term, right? So I want you to identify that there are four of these terms because we're going to have to do something to all four of those here in a second, so that we can cancel out the fractions. But if you don't do this next thing to every single term, you're not going to do it correctly and you're never going to get to the right answer, okay? So we have four terms. We have one, two, three, four terms, but we only have one, two, three fractions. Are you guys okay with that?
Yes.
Yeah, so this one is not a fraction, so we don't have to worry about this guy too much. What we need to do next is identify the least common denominator. And I say this kind of slowly because there's a lot of phrases and terms that we learn in math. We have to get that vocabulary down. But sometimes it kind of feels like math educators and mathematicians are just saying, oh, here's another three-word term, least common denominator. And that sounds a lot like greatest common factor, but those aren't the same thing, okay? Least common denominator is this idea that if we wanted to add fractions together by hand without using a calculator, we need to get them all to have the same denominator first. Okay. And the way you would do this is usually you would find a multiple of 2, a multiple of 3, and a multiple of 6 that are all the same. Okay. But then again, right, I'm asking you to find the least common denominator, but it requires you to know what a multiple is. Okay. So do you guys know what multiples of 2 are? multiples. What are the multiples of 2?
1 and 2.
No. So that's a really common mistake. Students will I will ask, what are the multiples of 2? And then they give me the factors of 2,
Counting
right?
by twos.
Like 10,
Multiples is counting by that number.
yeah, like 2, 4, 6, 8, 10, 12.
Exactly. Those are all multiples of 2. Factors, on the other hand, are breaking down the number into smaller pieces, but multiples are counting up into bigger numbers. Okay? So multiples of 2, like you guys said, are 2, 4, 6, 8, 10, 12, 14, 16, and you could do this forever, right? Okay, so that's my multiple of 2. But in this problem, I'm looking for the least common denominator, which means I need to find multiples of 3, and I need to find multiples of 6. Okay? So I'm going to go over here, and I'm going to write the multiples of 2. This is going to be multiples of 3. I'm going to switch to maybe red. So 3, 6, 9, 12, 15, 18, 21, 24, and so on. Okay? And right now, we're just listing some number of multiples. I'm not doing this with any rhyme or reason. I'm just counting out multiples so that I can see maybe several multiples of 2, several multiples of 3. Can you guys give me multiples of 6 now?
6, 12, 18, 24, 36.
You missed 30, but 36, 42, and so on.
It would be 12.
Yeah, exactly. So when we're finding the least common denominator, what we're really doing is looking for the least common multiple of the denominators. And so that is literally the smallest multiple that all of these lists have in common. So somebody said 12 earlier, and 12 is a common multiple here, but it's not the smallest common multiple. And I think Tori said it in the chat. It's 6. Because all of these lists have a 6 in common. So 6 is the least common multiple. In this case, since we're talking about fractions, we'll call it least common denominator is 6. Any questions, comments there? Okay, so you want to be careful here. We want to find the smallest common multiple. I think that using the word smallest makes it a little bit clearer for some reason, but we want that smallest common multiple, or that LCD is what we'll call it, because we need to use it in this equation somehow. So I'm going to put LCD is 6. Okay, so maybe I'm going to write a little division over here, this little partition to keep my notes separate from the work that we're doing over here on the left-hand side. What I'm going to do is we're going to hold off on using this LCD here for a second, because I want you to think about these fractions for a moment. I'm going to write my problem here. I'm going to write the first term, which is 1/2, and I'm going to put like a little bucket, a little blank space over here. I'm going to write here, this is just a bucket. I'm going to put something in that bucket. But I want you to think about this problem. A fraction like 1/2 is just a division problem, right? So this is literally the same thing as 1 divided by 2. What is the opposite of dividing by 2?
Multiplying.
Multiplying by 2. Are you guys okay with that?
Mm-hmm.
So one way that you can take an equation that has fractions and remove all the fractions is by canceling out the division of the denominator by just multiplying the denominator in. So if I wanted to, I could multiply this term by 2, and then I know that if I multiply by 2 and divide by 2, then those will cancel each other out. Are you guys okay with that logic?
Yes.
Okay. The problem is that this is not just one term. I have a whole equation over here. And if I multiply a number by any one of the terms, I have to multiply that number by all of the terms. So what I'm going to do is I'm going to rewrite the equation, but I'm going to put this little space or this little bucket in front of every single term just to make sure that I truly do multiply that 2 by every single term. So I'm going to have a space, then 1/2 plus a space, and I'll put this little bucket here. And then I have my next term, which is x over 3 equals, I'm going to put another little bucket here in front of the 1. Then I'll put the 1 down. Then I have a plus. I'm kind of running out of space, but I'm going to put a little bucket here. And I hope you guys don't mind. But on the other side of that bucket, I'm going to put 5 over 6. So don't be too alarmed that I'm running into this little line that I drew before. Okay. And in that bucket, like I just said, if I multiply a 2 to cancel out this denominator here, I have to multiply that 2 by every single term. So I'm going to put that 2 in every bucket. Okay. Questions, comments up to that point? So this is why I had you guys count the terms, because for each term, visually, I put a little space or a little bucket in front of each of the terms to fill in what I need to multiply to cancel out a denominator. Okay. So if I multiply 2 here, I'll cancel out that 2. But notice that on the next term, I have x over 3. In other words, x divided by 3. 2 is not going to cancel out the 3. What number do I need to multiply by this fraction to cancel out its denominator?
3.
A 3. Yeah. And so if I want to do that and cancel out the 3, I need to cancel out by multiplying a 3 here. So not only am I going to multiply a 2 by everything, now I need to multiply a 3 by everything. So I'm going to go back and fill up my buckets with a factor of 3. And then I'll continue looking at my fractions here. Okay, I'm going to zoom in so you guys can see this a little bit clearer. Any questions, comments? So for now, it might seem like a lot of writing, but in a moment, things are going to clear up. We just kind of need to go through the hard part or a lot of writing part, and then it'll be a lot simpler when we start looking at it. Okay. So we're looking at each term, and we want to cancel out the fractions. So we want to kind of cancel out their denominators. By multiplying a 2 through the entire equation, we'll cancel out this denominator. By multiplying a 3 through the entire equation, we'll cancel out this denominator. This next term, the 1, isn't a fraction. So there's nothing that we want to cancel out. There's no denominator here that we want to get rid of. This last term, 5 over 6, has a 6 in the denominator. So what do I need to multiply by this fraction to cancel out its denominator?
No, will it be anything because 3 times 2 is 6?
That's exactly right. So if we said, oh, we need to cancel out a 6 here, so let's multiply a 6 through the entire equation, guess what? All of these 2 times 3s, they're the same thing as 6, right? And this kind of brings me to this idea of, well, what is 2 times 3 anyway? It's this LCD, right? That is the 2 times the 3.
Oh.
Okay, so if we know that 2 times 3 is 6, we don't have to multiply anything extra here because this 2 times 3 will cancel out this denominator of 6. Does that make sense?
Yes.
Okay. Any questions, comments before we proceed? Now I said, I know that this looks like a lot of writing. The next step, once we identify the least common denominator, sort of, and there's 2 ways we could do it, right? We could do it by thinking about how do we cancel out the denominator, or we could have just done what we did over here where we made a list of the common multiples, okay? The next thing is to use the common denominator. I'm sorry, the LCD. Let me get my, what do you call this? What is this stuff called? Whiteout?
Tape, why don't?
Yeah, my whiteout tape. Use the LCD to clear all the fractions. So how are we going to do that? Well, we're just going to go through this equation that we wrote down with all our little buckets and all our little factors, and we're going to cross out any common factors. So for this first term, the 1/2, we can cross out the 2 with this denominator because that's a common factor. We're multiplying by 2 and dividing by 2, so those cancel out. What's left over?
3 times 1.
3 times 1, right? And what is 3 times 1?
3.
It's just 3. I'm going to bring a 3 down. Then I'm going to put my plus sign. I'm going to go to the next term with my next bucket. And which of these factors in the bucket is going to cancel out this denominator?
3.
So we're going to cross out the 3's. What's left over?
So would it be 2x?
It would be 2x. So we're going to bring that down. And then we're going to move on to the next term, right? I have my LCD here in the bucket, the 2 times 3. And this is just a 1, right? Did it have a denominator to cancel out?
No.
No. So I'm just going to multiply what I have here to simplify it. So what is 2 times 3?
6.
Times a 1?
Oh, I did 2 times 3.
Yeah, I mean, it's 2 times 3 is 6. Times 1 is still 6.
Still 6.
So I'm just going to bring down to 6. And then finally, if you think about this bucket as one thing, 2 times 3 is 6. So the 2 and the 3 will cancel out with the 6. And what am I left with?
5.
Just that plus 5. And I'm going to bring that down. Are you guys okay with that?
Yes.
Okay, well now I have this new equation, right? And let me just sort of put it together so there's not so much space. 3 plus 2x is equal to 6 plus 5. This equation no longer has fractions. And so finding the LCD or figuring out how to clear all of those denominators brings us back to a type of equation that should be easy to solve because this is just a linear equation, which means that you need to isolate the variable x in this case. We just need to get x by itself, okay? So what that might involve is that we need to simplify the equation a little bit. Can I combine like terms? Well, 3 plus 2x, there's nothing to do over here because those aren't like terms. But what is 6 plus 5?
11.
It's just 11. So I'm going to bring down 11. 11 is equal to 3 plus 2x. And if I want to get this 2x by itself, how do I move this 3 over to the other side?
Subtract.
I'm going to subtract that 3 over to the other side. So now I have 2x is equal to 11 minus 3 is?
8.
8.
So I'm going to put that 8 down. And then what's the last step for getting x isolated?
Divide 2.
Divide by 2. So x is equal to 4. Okay, so the fourth step is really to simplify, which means sometimes you'll distribute. In this case, we didn't have to distribute, but you'll definitely need to combine like terms just to make things look a little bit nicer, a little bit cleaner. And then 5 is to solve the equation by whatever means necessary. If that happened to be a linear equation, well, then it's easy. We're just getting x by itself. But if it's a quadratic equation, then you have to remember all of your steps for solving a quadratic equation. But we're really just using this idea of, can we cancel out the denominators, build the least common denominator, in other words, and move on to an equation that no longer has fractions, and then we can go back to something like the equations we saw in test 1 or test 2. Okay. So that's the real the key, the fundamental key for solving these types of equations. You want to manage your anxiety because I know fractions look crazy, they look intimidating, but if you break them up into pieces and say, how do I cancel out this denominator? How do I cancel out that denominator? Eventually, you'll hopefully put the pieces together so that you can go and cancel those common factors like we did here. Okay. So this was just a little, I would say, toy example. We're going to look at something that's actually a rational equation that might be harder to deal with. But before we move on, does anybody have any questions or comments about this one? Let's get a vibe check. Did that seem like the hardest thing that you've ever done in your life?
No.
Awesome. Okay. Well, the next thing is to go back to the PowerPoint and just recognize that in the PowerPoint, I do things slightly differently, but hopefully the explanation is all there. We started off with this equation, just to quickly recap, and we said, what's the LCD? So one way that we do this is by building the LCD from scratch. So if you look at the denominators 2, 3, and 6, and if you just quickly write down a list of those common multiples, you'll figure out that the LCD is 6, which is the same thing as 2 times 3. So when you're solving these kinds of equations, if you have like a more complicated denominator or a bigger denominator, look to the smaller denominators because usually those are factors of the bigger one. Okay. And
Question.
so, yeah, go ahead.
So on the left side where you said 3 times 2, if
Mhm.
we do that part like in our head that we know it's 6, do we have to write those steps down or they're not always going to be like that?
They're not always going to be that easy.
Okay.
And certainly in the next example, we're going to see that like this one is a linear equation. What I mean by that is all of the denominators are just numbers. But in the next problem and in the next couple of problems, we're going to see problems where we have variables in the denominator and you can't find the LCD that easily. It's still going to be pretty straightforward, I think, but it's not going to be as easy as multiplying the two smaller ones to get the bigger one. Okay, so just keep that in mind. If it still feels a little bit blurry, hopefully it will be revealed here in time. Okay, but for this problem, we made a list. We found the LCD by just listing out multiples of 2, 3, and 6. We said it was 6. So in the PowerPoint, what I do is instead of writing the bucket with 2 times 3 on every single term, I just multiplied by 6. Okay, so here you can think about what is 6 divided by 2. Well, if I kind of partially cancel that out, I'll end up with a 3. What is 6 divided by 3?
2.
Yeah, I'll get a 2 here. And then there's nothing to cancel here because I didn't have a denominator. But then like we said when we worked this out on paper, 6 divided by 6 cancels out completely, so I should get a 5 down here. Okay, so the way that's going to look in the PowerPoint is more like this, where I just canceled the common factor and then I left over what was remaining. Okay, on paper, I kind of simplified that before I brought stuff down, but 3 times 1 is 3, like hopefully what you guys have written down. And then I brought down a 2x. And then 6 times 1 is 6, so we brought down a 6. And then we canceled everything out for that last term, and so I just brought down a 5. So it's exactly the same stuff, just written slightly differently. I just don't want that to confuse you if you go back through the PowerPoint. Okay. But ultimately, what I ended up doing is getting an equation that no longer has fractions. So I said to myself, let's go ahead and simplify this. 3 times 1 is 3. 2 times x is 2x. 6 times 1 is 6. And so I have this equation, which ultimately is what we got on paper. Okay. And then since this is just a simple linear equation, we said, let's just get the x by itself, right? So here, I just combined the like terms, the 6 and the 5 became an 11. And then it's just a matter of getting the x by itself. So we subtracted the 3 over to the other side, then we divided by the 2, and we got x is equal to 4, right? And again, that's just a quick recap of what we did, but if in that recap you had questions, feel free. Were there any questions that came to mind here with that replay? You guys ready for the next one then?
Mr. Aguilar.
Yeah.
So say like instead of like -3,
Uh-huh.
does it really matter what side we really divide it by?
So when you say, I'm a little bit confused by your question. You said the -3.
Oh, yeah, you take away the 3. What if you do like 11 instead of 3?
Oh, I see, I see. There we go. So if we said we have 3 plus 2x equals 11, and you subtracted 11 here. You could do that. That's perfectly legal. You just have to subtract an 11 over here. What I think that a lot of students make a mistake of is when they start canceling stuff out, they forget to put this 0 down. So as long as you put that 0 down, you're okay. 3 minus 11 is going to end up giving you a -8 plus 2x. Does that make sense to you?
Mhm.
But now, Ian, what would be your next step? Because we still need to get the 2x by itself. What would be your next step there?
Then you just have to move the 8.
Yeah. Yeah, and then so you would have to add the 8 to both sides. Are you okay with that?
It'll just give you the same answer.
So that would still give you the 2x plus the 8. And the only reason I wouldn't advise doing that way because is just because now you move the 11 over here only to move this number back to the right-hand side. When the way we did it when we subtracted the 3, we just needed to move it over to the right, and now the x is by itself, so then we can just divide by 2. So you added an extra step by moving things over. That doesn't mean that it's wrong, but I think that if you do it with more steps, that's just more opportunities to make little mistakes.
I see. Okay.
So, do it in the way that feels comfortable for you, because ultimately what you feel comfortable with will result in fewer mistakes. And at the end of the day, that's all we're really looking for. If it makes sense mathematically, then you can do it. You can do whatever you want, as long as it makes sense mathematically. Okay. All right, here comes the hard stuff, okay? So we have this rational equation here, and there are 3 terms in this rational equation. We have 16 over x plus 2 equals 1 plus 2 over x minus 4. So not only do we have numbers in this problem, like our numbers in our numerator, but the denominators are actually polynomials. They're binomials. We have x plus 2 and x minus 4. So now we're going to solve this rational equation, but we need to take care of certain things like restricted values are going to come back to play, just because a restricted value is an x value that cannot be a solution to the equation. So we need to sort of make a note of what our restrictions are here before we dive into solving the equation. So solve this rational equation. And let me go ahead and write this down real quick and we'll jump in. So this is 16 over x plus 2 equals 1 plus 2 over x minus 4. I'm going to do the same thing I did before where I put a little line down this side of the paper so I can make my notes. And then we'll sort of annotate as we go along. Okay. Can you guys tell me how many terms are in this equation?
3.
Yeah. 1 term, 2 terms, 3 terms. There are 3 terms. Okay. So when I think about making these buckets of things I'm going to multiply into my equation, just know I need 3 little buckets in front of each of the terms. Okay. For these rational equations, we actually have to find all the restricted values first. for each term. Okay. So if you recall, a rational expression is one that has a variable in the denominator. So this first term is a rational expression and it has a variable in the denominator. The restricted values are going to be whatever value of x forces this denominator to turn into 0. So what could I plug in for x that when I add 2 to it, it will make this become a 0?
-2.
-2. So what I'm going to say is that my restricted value x cannot be -2. Are there any questions about the restricted value for this first term? So some of them will be easy to just kind of look at the denominator and you'll be able to say, oh, if I put a -2 here, or the opposite of +2, that's going to be restricted because -2 plus 2 would be 0, and I can't divide by 0. But if you want to go the long way, you can say set x plus 2 equal to 0, solve this equation, and I get x is equal to -2. And that's how I knew that my restricted value was a -2. Does that make sense?
Yeah.
Okay. The next term, is this a fraction?
No.
So I don't have to worry about it. Okay. It's not going to have any restrictions because I don't have a denominator. Okay. Or I don't have a variable in the denominator. So I'm going to move on to the next rational expression. This guy. Can you guys tell me what the restricted value is by looking at its denominator?
4.
Yeah.
4.
X cannot equal +4. Right? Because 4 minus 4 would give me a 0, and I don't want that. Okay. So for now, I'm going to set aside my restricted values. I found them at the very beginning before we even started solving this equation, and that's going to come back into play later. What we're going to do now is go through kind of the same steps that we saw on the last problem and solve the equation. Once I get my solution or my solutions, in the case of multiple solutions, the way you're going to check them is that you need to make sure that they're not restricted. So if I get some answers here that are not -2 or 4, then I can say those are valid. Okay. So this is just a quick way to check so that you don't have to plug things back into the original equation. So I'm trying to save you guys a little bit of time and a little bit of heartache here. Find those restricted values at the very beginning of the process, and then we can dive in and actually begin solving the equation. Okay. The next step. I like to say for this next step, especially for rational equations where the denominators are these kind of ugly things with variables, that we want to build the LCD. Okay. So what I mean by that is we're going to go term by term and ask ourselves, what do I need to multiply by this first term so that I can cancel out the denominator x plus 2?
X plus 2.
Hey, I need to multiply an x plus 2 by every single term. Does that make sense?
Yes.
Can you say that again? I'm sorry, I missed it.
Yeah, so you have to ask yourself, looking at this term, 16 over x plus 2, what would I multiply by this term to cancel out its denominator?
Okay, the x plus 2.
It is x plus 2,
Mhm.
right? Just like we saw on the previous example, we looked at that first term and said 1 over 2. How do I cancel out the denominator? Well, if this is 1 divided by 2, then I just need to multiply by 2 to do the opposite, right? So even though this is a complicated thing, 16 divided by x plus 2, that divided by x plus 2 is the key because I need to multiply an x plus 2 to cancel out that division. So that's why I'm going to put x plus 2 as part of my LCD. Then I'm going to move to the next term. I'm going to ask myself, is there a denominator here? Do I want to cancel anything out here?
No.
No, it's not a fraction. We don't have to worry about this one. Okay, so then we can move on to the last term. The third term is 2 over x minus 4, or if you want to think about it as 2 divided by x minus 4, what do I need to multiply by this term to cancel out the entire denominator?
X plus 4.
I'm going to put not x plus 4, x minus 4, the exact same thing as the denominator. Right? So don't get it twisted. Remember, it's easy to make that mistake, but if you look at any of these terms, if I said, oh, I want to cancel out the 2 here, I didn't multiply a -2 to cancel out the 2. I multiplied that exact same value with the exact same sign. Same thing with this one. When I said I want to cancel out this 3 here, we multiplied a +3, not a -3. Okay? So for these, you need to really pay attention to the signs. To cancel out the x plus 2, we just put an x plus 2 in our LCD. To cancel out the x minus 4, we put an x minus 4 in the LCD. Does that make sense? Is that clear?
Yes.
Okay. Now, maybe it doesn't seem like crystal clear, but in the next step, hopefully you guys will see that the reason why we do this is because it's going to work to cancel out those fractions. So I'm going to now build the LCD and use the LCD to clear all fractions. So what I need to do is rewrite every single term, and this does take a lot of writing. I'm going to put 16 over x plus 2, but I'm going to put a bucket in front of that term. Okay, and I'm just putting a bucket just to visually show what I'm doing. Usually I don't actually write the buckets, okay? But I think like to see where you need to put things on your page, I think it's really useful just as a teaching aid. Then I have 1, but I'm going to put a little bit of space in front of it because I need to put a bucket here, right? I'm going to put my LCD in these buckets. Then I have a plus. I'm going to put a bucket here. And then I'm going to put my last term, which is 2 over x minus 4. And what am I putting in the bucket? I'm putting the LCD in the bucket, okay? But the LCD is both of these factors. So I'm going to put x plus 2 times x minus 4 in this bucket. And every single bucket needs to contain that same stuff. So x plus 2 times x minus 4. And then x plus 2 times x minus 4. So you can see already that it's kind of a lot of writing. If you're the kind of student that is trying to cram everything down into the smallest like square of space on your piece of paper, this is going to go terribly. You need to give yourself enough real estate on the page so that you can actually think through this problem. If you're trying to squeeze it in, you're going to make mistakes, okay? Because it's a ton of writing. Are you guys okay with filling up the buckets with the LCD?
Yes.
Okay, well now step 4 says to use the LCD and we're going to clear the fraction. So now we're just going to cancel any common denominator. So we're going to go term by term to see what cancels. So for this first term, which of these factors is going to cancel?
X plus 2.
So I'm going to cross out my x plus 2's. Okay, what's left over?
16.
16, and what else?
X minus 4.
And x minus 4. And it doesn't matter, it doesn't matter that I switch the order there. If you have a 16 and an x minus 4, the only reason I'm putting the 16 first is because I think that most students are used to having the number in front of the parentheses whenever we get ready to distribute. So sometimes students get confused when I have x minus 4 and then I put a 16 on the right side. So you can switch the order if you need to, if that feels more comfortable. Do that, okay? So that's the first term. We canceled out a common factor. We brought down what was left over. The next term, we have these two factors times 1. Does anything get canceled out?
No.
No, because we didn't have a denominator for our fraction. In fact, we didn't have a fraction here. So what am I going to bring down here?
1 and then x plus 2, x minus 4.
Hey, I'm just going to put x plus 2 and x minus 4, and I'm going to ignore the 1. Why am I doing that?
But it's understood nothing's there.
Well, it's not, I wouldn't put it that way. What I would say is that if you have a 1, these things are being multiplied. What happens when you multiply 1 times anything?
You
You
were
get
saying.
It stays the same. So I would say when you multiply 1 times something, nothing happens, right? So that's why I can just say, oh, if I multiply the 1, I can just drop it because it's not going to change the problem at all. Okay. And now I can move on to the last term. So I have these factors in my bucket, and I have this term over here, which is a fraction. What factor is going to cancel out that denominator?
x minus 4.
Yeah, so I'm just going to go and cross out the x minus 4s, and I'm left with 2 times x plus 2. Are you guys okay with that? Questions, comments? Okay, so in reality, I think if we take a step back, we take a breather right now, notice that the only new or scary thing that's going on here is trying to figure out what is the LCD and then canceling common factors. Because if we can do that correctly, then we end up with this new equation that, yes, there's a lot of things to clean up because we have a bunch of parentheses, but we don't have any fractions. And that's what we were trying to accomplish, clear all the fractions. So if for some reason you do this step, you go 1, 2, 3, and then you get to this new line and you still have a fraction, well, then you've made a mistake. You didn't clear the denominators correctly. Okay. So are you guys ready for the next step? The next step is to just simplify what we have here. So I'm going to zoom out and hopefully you guys can still see this. And remember, when we're simplifying an expression or an equation like this, we want to distribute everything that we can and then combine like terms if we can. So think of yourself like the cleanup crew, and we just want to clean up this equation because right now it looks really messy. Combine like terms. So what I'm going to do is say to myself, what is 16 times x? Well, that's just 16x. What is 16 times 4? Sorry, negative 4. It's going to be negative 64. Are you guys okay with that?
Mm-hmm.
So you want to take your time here. When you have these two binomials, we need a FOIL or just distribute that out. So x times x gives you x squared. X times negative 4 gives you a negative 4x. 2 times x gives you a positive 2x. And then 2 times negative 4 gives you a negative 8. You guys okay with that?
Yes.
Finally, I have a positive 2 here that I'm going to distribute, multiply it by x, and also multiply it by 2. So that's going to give me a plus 2x and a plus 4. And this thing is looking like alphabet soup, which is why I said you pretend that you're the cleanup crew. We had to distribute it. We had to get everything sort of out of the parentheses. And now we can combine like terms. So we're going to take our time on the left-hand side of the equation. We just have a 16x and a 64, but we can't combine those. Those are not like terms. So then on the right-hand side of the equation, we can ask ourselves, do I have any x squares to combine? Well, that's a no. Then we'll move on to the minus 4x, the plus 2x, and the plus 2x. right? So I'm circling these just to use a shape to indicate that these are my like terms. I'm going to combine all my circles, right? So what is -4 plus 2 plus 2? Yeah, Tori in the chat said it's 0. Okay, and if you need to, you can grab your calculator at this point and just say -4 plus 2 is 0. So if we get a 0 when we're combining like terms, that means that we canceled out these terms. So we don't have any x's left because the -4 canceled out the +4 if you want to think about it that way. Then we have a -8 plus a 4. So what I'm going to be left with is x squared, and then -8 plus 4 is a -4. And then I'll just bring my 16x and my -64 down as well. What kind of an equation is this?
Um,
Believe in yourself.
quadratic?
Yeah,
Yeah.
that's exactly right.
Oh,
It's quadratic. How do we know it's quadratic?
that's 4 terms.
No. Swing and a miss. But 1 out of 2
The
is
x squared.
it's the x squared, right? Remember, quadratic means cuadrado, which means squared. So if you don't learn any math from this class, years from now, I hope that you remember a little bit of Spanish. But being able to identify this as a quadratic is really helpful because you now know to solve this equation, which is the 6th step, solve the equation, you know a couple of things about what you expect here. If it's a quadratic equation, how many solutions am I going to get?
4.
No, not 4.
2.
2.
2, right? Because the quadratic equation has an x squared. So the highest exponent or the degree tells you how many solutions you should expect, right? Just like when we were solving the x to the 3rd power equations, we expected 3 solutions from that. When we saw x to the 4th power, we expected 4 solutions from that. So we should be remembering, and hopefully, this jogs your memory, that we should expect 2 solutions here. We do need to get this in standard form. So I'm going to go ahead and subtract the 16x and add the 64 so I can move them to the other side. So I'm going to subtract 16x and add 64 so that now I get these guys will cancel out. So I have 0 is equal to x squared minus 16x, and then this is going to be plus 60. Are you guys okay with that? I'm going to put you over here. This is standard form. And also that we expect 2 solutions here. Okay. I'm going to zoom back in a little bit. Questions, comments before we proceed? Anything at all, just a general vibe check.
Mr. Aguilar, I was wondering about like the question.
Which question?
At least with this one, I noticed like there's like will all like the questions, will they all have like a fraction and like a whole number like this one? Or can all like numbers be like fractions?
They all could be fractions.
Okay. I
Yeah,
was just
but
wondering like how the formatting might work.
yeah, so sometimes you will get a whole number in them, but in other problems, in another example we'll see here in a second, they'll all be fractions. Okay. But, what I want to point out here is that I would say if I had to like sort of draw a line in the sand to say what is new versus what is old, the new stuff is up here. This is the new stuff. Because distributing and combining like terms and then solving a quadratic equation, everything from this line down is old material. Okay, so it's not, I'm not ignorant to the fact that maybe some of us need more help with solving quadratic equations. But like I have to reiterate this analogy that I've been using since the beginning of the semester, which again, I know this is a summer class, so it's hardly a semester, but we are building something here, right? Every topic that we cover in this class builds off of the last. So like at the very beginning of the semester, really the beginning of module 2, I said factoring was going to be super important for the remainder of the semester. When we started solving quadratic equations, I said solving quadratics is going to be foundational to everything we learn beyond this point. So everything is going to come back to bite you in the butt if you don't remember the old material. So if we need to get that extra practice, there's no time to delay. You need to go to Math World. We need to get a one-on-one time with either you and the tutors or with you and myself. We need to set that up because we want to sort of uh, go all in here in this last 3 weeks, right? Give it all that we can because if we're able to pull out the win, if we're able to pass this class, you guys won't ever have to solve a polynomial or a rational equation ever again, right? We're too close to the end zone here to sort of sacrifice it by like taking it down when we could go for that touchdown. Switching up my analogy to football for some reason. Okay. So just bear with me here. We should be able to solve a quadratic equation. If I have 3 terms in this polynomial, what do I want to do to go about solving this?
AC method.
We want to do the AC method. Or, if you're afraid of factoring, you can use the quadratic formula. But I say if you're afraid of something, run towards it. It's the only way we're going to get stronger. If we're going to grow, we need to face our fears. So we're going to use the AC method to factor.
Continue.
And then we're going to use the zero product property. Now, do you guys want me to go through the quick method of factoring? I know that Corey probably does. But if there's somebody out there that wants me to go through the full AC method, I will definitely do that. Do you guys want to see the full method? Okay, I got a yes in the chat. We're going with the full method. Okay, so remember, A is equal to 1 because there's a 1 in front of this x squared. B is equal to negative 16 and C is equal to 60. So what we need to do is multiply the, sorry, I underlined the wrong thing. We need to multiply the 1 times the 60. Let me get rid of this little line here because that's going to be pointless. Don't want to confuse anybody. 1 times 60 is going to be 60. So we can look at all the factors of 60, which are 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and 6 and 10. 7 doesn't work, 8 doesn't work, 9 doesn't work, and then we're back at 10. Which always makes me think of Brian McKnight. We start back at 1. Okay, anyway, if anybody remembers Brian McKnight, it's a classic, Back at 1. Go back and listen to that track. Okay. And we need to pick the factor pair that's going to add to give us the negative 16. So which of these looks like it's going to give us a 16?
6 and 10.
Yeah. So I'm just going to box in the 6 and 10. Now, straight up the way they are, 6 and 10 aren't going to give us a negative 16. But I can make them both negatives because that will give me the negative 16. And if I multiply them together, they give me the positive 60, right? So that's going to work. I'll go over here now and say we have x squared minus 6x minus 10x plus 60. And then I can begin factoring by grouping. So these two guys have an x in common. So we have x minus 6. These two guys have a negative 10 in common. So we have x minus 6. So we should get x minus 6 and x minus 10 equal to 0. And then I'm going to give you guys a moment to sort of collect yourselves because I know that was kind of fast. But were there any questions about the factoring out the GCF part of that factoring by grouping stuff? Okay. So once we get down to our factors here, we can apply the zero product property, which just says, let's set these up as little equations. X minus 6 equals 0, x minus 10 equals 0, and then solve those, right? So how do I need to get the x by itself? What do I need to do here?
Plus 6.
Plus 6. So x is equal to positive 6. That's one of your solutions, maybe. And even though I said maybe right now, and you're thinking to yourself, oh God, what does he mean? We're just going to ignore that for a second and move over to the last equation and say, well, how do I get the 10 or the negative 10 over to the other side?
Plus 10.
Plus 10, right? So solving these linear equations shouldn't be too hard. We'll get x is equal to positive 10, and that's possibly one of our solutions. Okay. Here's step number 7, which is to check your solutions. But really, we're just going to cross-reference them. Okay? Because even though we got lost in the weeds quite a bit, we had to cancel out some fractions, we had to distribute out a bunch of stuff, and then we got a quadratic equation, and we had to call back the AC method and go through the factoring, use the zero product property. We got our 2 solutions. If you put these 2 solutions in haphazardly into ALEKS, you may be incorrect. Okay? We're going to check the solutions to make sure that they're not restricted. And what I mean by that is, what were the restricted values that we found at the very beginning of this problem?
Negative.
-2 and 4.
So these are the only 2 solutions, or the only 2 numbers that can't be solutions. If we got something different, then that's valid, right? This 6 is not a -2 or a 4, so it's not restricted. This 10, also not a -2 or a 4, so it's not restricted. So since these are both not restricted, then our solution set contains both 6 and 10. And then we're done with that problem. Okay? Like I said, when we were solving radical equations, I told you to take your solutions and you had to plug them back into the original equation. So like we could do that here if we wanted to. We could take the 6 here and then say, if I want to be super thorough, I'm going to take 16 over 6 plus 2 and see if that's equal to 1 plus 2 over 6 minus 4, plugging in that solution. But rather than doing that, when we're solving these in the homework or on the tests, the quick way that you can check is just make sure that those aren't restricted. If they're not restricted, you're good to go, right? Just put those in your solution set and move on to the next problem, okay? Don't make it more complicated than it has to be. Questions, comments, concerns about this problem?
What if it is restricted?
Oh, so let's think about that. If this 6 was a restricted value, for instance, let's say I solved this and my restricted value here was 6, right? If that's the case, then this is not allowed to be a solution. So I would have to cross this out, throw it away, and then my solution set would not contain the 6. I would only have one solution. Does that make sense?
That makes sense. And then what if the other one is -2?
If the other one's -2?
Undefined.
No,
Alex.
so this is exactly right. These are good questions. So let me erase some of this so that you guys have, it's nice and clean. I got really excited with my red pen there, just crossing things out. Okay, this was x equals, what do we get? We get a positive 6. And then this actual restricted value was a -4, right? Let me just make it simple for you guys.
Positive 4.
So restricted value, positive 4, -2. This is all good now. Okay. If you have one of these numbers is a restricted value, then you will throw it away and it will not be in your solution set. If you get 2 solutions from solving that quadratic equation and both of them are restricted, then ALEKS has a button, right, that says the empty set, right? That means that there is nothing in your solution set. Both of those numbers were restricted, and so you have no solution. Okay. So you have to watch out for this. Sometimes you're going to solve a quadratic equation and both of your solutions will be valid. Sometimes you'll have to throw one away because it's restricted and you'll only have one solution. And then in a really series of unfortunate events, you could work out an entire problem, take an entire page to work all that stuff out. And then when you check, the two answers you got are both restricted. And so you have to throw both of them away. Okay. But really, isn't college algebra just the friends that we made along the way? It's really about the process is what I'm saying here, right? If we're getting the process down, it doesn't matter what the outcome happens to be, okay? So don't feel like personally attached or personally offended if you have to throw away both solutions. Feel proud that you were able to get through the whole problem on your own and that you got the correct answer in ALEKS, right? Because those green check marks, it's like drugs, man. It's like heroin. It makes you feel so good for just 1 second, okay? And then you spend the rest of your life chasing the dragon, okay? So don't get too attached to these solutions because they may end up being restricted, in which case we have to throw them away and move on with our lives. And she's never coming back, so don't waste all your energy dreaming about her. She's never coming back, okay? Those are my jokes. Does anybody have any other questions about this particular problem? Well, I'm sure that you guys want to see another one. So all I'm going to say here is that in the PowerPoint, I go through this problem. It doesn't look exactly the way it looks like in paper, but as always, you can reference it. And I go through the same steps. So here's my play-by-play recap. Step 1, we identified all the restricted values. So I take any of my denominators, set them equal to 0, got my restricted values, and then I set those aside, right? Because I'm just going to use them later to check my solutions at the end of the process. Once we did that, we said, look at the denominators and build your LCD. So the LCD contained both x plus 2, because we wanted to cancel that out, and the x minus 4. If we don't have a fraction, like for this middle term, the 1, then we don't have to worry about including anything additional into our LCD. We just want to cancel out those denominators. So we set up our buckets, and then we multiplied the entire LCD by every single term. At this point, your paper is going to look like a mess of alphabet soup. But the nice thing is that when you go through this, even though it's a lot of writing, you're going to start canceling out common factors. And whatever's left over, you're going to write that down as your new equation that no longer has fractions. Okay? Now, this new equation is not without its own faults. You still need to distribute and combine like terms to clean up the mess. So that's exactly what we did. We distributed some stuff out, combined like terms, and got this kind of nicer, neater quadratic equation. If we know it's a quadratic, we know we're going to get 2 solutions. And also, we know that either we want to factor or use the quadratic formula. So here, I got it into standard form. I factored it, but just be aware that in the PowerPoint, I don't show the process of using the AC method because I'm assuming that you can fill in that blank, that you can go through the process and you'll get those 2 factors, right? Then I'm also assuming you can apply the zero product property by setting or zeroing out those factors and then getting your 2 solutions, right? So that's exactly what we did. We got our 2 solutions. And as long as those are not restricted, then we're good to go, right? Those are going to be our solution set and we can move on with our lives, okay? So just remember to double check those solutions because you want to make sure that they're not restricted. Sometimes students rush into these problems and don't find the restricted values and don't bother checking their solutions. And then ALEKS gives you that red X and everybody hates that, right? Okay, so you want to not frustrate yourself and always start by finding those restricted values. In the event you have to throw away all of your solutions, then Alex is going to have that button for you to check. It's going to be that empty set, the curly braces with nothing in them. That means that you have no solutions, and that's perfectly fine. Like I said, this class is about the friends we made along the way, not what solution set we ended up getting. Okay. All right. In the interest of time, I gave you 4 problems here that you can use to practice, and you can go to Math World and check to see if you did these correctly. Okay. You don't have to do all of them. In fact, we only have time to do one of them because I want to give you guys time to do some homework and ask me some questions. So let's take it to the chat. Let's vote. Which of these problems do you guys want me to work? Go. Put your answer in the chat.
I changed my answer to D because that's the only one that has like a plus and a minus and 3 terms.
Well, C and D both have 3 terms.
Oh, I mean like in the denominator.
Oh, it has like a plus and a minus in that first denominator. I
Yeah.
see.
All the other ones are kind of the same with pluses.
I think that I worked D earlier with my face-to-face class, and to me, it seemed a little bit too not complicated, but I think it seemed different from what you guys are going to see in your homework. So I'm going to go, it looks like most people are saying C or D. I'm going to work C with you guys. Okay. Just because I think that it might end up being more similar to what you're going to see in Alex. But it's going to be the same kind of mechanic. So I'm going to work through it. Let me write it down. We're going to do C. I'm taking my executive action there and making the final decision. So we're going to go with 2 over x plus 3 minus 3x plus 5 over, this one's x squared plus 4x plus 3 equals 5 over x plus 1. So what I'll say this is if you like absolutely want to see me work out D, then after we sort of go into breakout rooms and I let you guys do some homework on your own, at the end of class when I dismiss you, if you want to hang back and watch me work on D, I can do that. Okay. But it's a little bit needlessly complicated, I think. And so I think C is going to be a better sort of like fodder for you guys to study. So let's take a look at C, and hopefully I'm not wrong here. I haven't solved these in a minute. Okay. So I'm going to try to do this a little bit faster, so stop me if you have questions. Unmute yourself, yell at me, do what you got to do, put something in the chat. Solve the rational equation. Okay. First thing I'm going to say is, most of the time when I solve these, I say, tell me the number of terms. I'm going to stop putting that as step 1. Because I think that you guys can count how many terms are here, right? Can you guys tell me how many terms are in this problem?
Yeah.
Yeah.
3. Okay. So we know how many terms there are. So I'm going to go straight into find the restricted values. Okay. And I'm going to do this by the book. So I know that you guys can look at this denominator, x plus 3, and you can probably tell me what this restricted value is. But I'm just going to go with x plus 3, set that equal to 0. I'm going to solve this and subtract 3 from both sides. So I know my restricted value, x cannot be equal to -3. You guys okay with that?
Yes.
Okay. Again, for this, if you were showing your work and you just said, oh, restricted value is -3, this one's a simple enough denominator that I wouldn't have any problem with you just saying it was -3. Similar, I'm going to go to this easy one, skipping the middle term for a second, and say, okay, by the book, x plus 1 equals 0. I'm going to subtract 1 on both sides. So my restricted value here is x cannot be equal to -1. Are you guys okay with that?
Yes.
Okay. Now, this middle term is a quadratic factor or a quadratic denominator, right? We have x squared, quadratic, cuadrado. So we need to set that equal to 0, x squared plus 4x plus 3 equal to 0, and that's a quadratic equation. So to find the restricted values here, first, how many restricted values is it going to give me?
2.
2. And then since it's a quadratic equation now, how do I solve it?
The AC method.
Factor it.
Factor it. Use the AC method. Exactly right. So because, we're short on time, I want to go ahead and just do the quick method here. But if you need to, write a little note to yourself, do the AC method. What you're going to end up with is we need an x and an x, and then we need factors of 3 that are going to give me 4. So that's going to be 1 and 3. And they both need to be positive in order to add to give me that 4x. So if I use my zero product property, x cannot be equal to -1 or -3. But those are the exact same restricted values that we had before. Okay. So in reality, the restricted values are just -3 and -1. We don't have to like write it twice. We ended up getting the same restricted values. Any questions about that restricted value part? Two, I need to build the LCD and use it to clear all fractions. So I'm sort of combining some steps now. LCD. Okay. But before I do this, I'm going to rewrite this problem and set up my buckets. Okay. So I'm going to write 2 over x plus 3, and I'm going to put a little bucket in front of it. Then I'm going to put my minus sign. I'm going to put a little bucket. And then for this second term, I have 3x plus 5 over, I want to write this in factored form. Whenever I have a complicated quadratic denominator, I want to write it in factored form, and we factored it over here when we were looking for the restricted values. So instead of putting x squared plus 4x plus 3, I'm going to write it as x plus 1 and x plus 3. The reason I'm writing it in factored form is just so that I can see what's going to get canceled out once I build my LCD. And then finally, didn't give myself a whole lot of room here to work, but I'm going to put a little bucket here. And then my last term was 5 over x plus 1, and hopefully that's not going to be too confusing with some of this scratch work I have over here. I'm going to zoom in so you guys can see it a little bit clearer. Are you guys okay with me setting up each of the terms and setting up my buckets?
Yes.
Yes.
Any questions out there? Okay, now we can think about building the LCD. So for this first term, what do I need to include in my LCD to cancel out the x plus 3?
X plus 3.
Hey, I need an x plus 3. Okay, I'm going to move on to the next term. This term has 2 factors in the denominator that I want to cancel out. So I have an x plus 3 in my LCD already, so I don't need to double up. But if I want to cancel out the x plus 1, what do I need to add to my LCD?
X plus 1.
I need to put an x plus 1 here. You guys okay with that?
Yes.
Then finally, I'll look at the last term, which is just 5 over x plus 1. And as long as I have an x plus 1 in my LCD, it's going to cancel out that denominator. So do I have to add anything else to my LCD?
No.
No. Again, I don't care about the numerators here. So when you leave class today, do not convince yourself that you needed to do anything special with the numerators. We're just concerned about canceling out those denominators. So if we build this LCD correctly, then we can put those in each of these buckets. So I'm going to put x plus 3 times x plus 1. X plus 3 times x plus 1. X plus 3 times x plus 1. And I didn't leave myself a whole lot of space, so I apologize for that. But we filled up our buckets with the LCD. Okay? Questions, comments? So the next step is going to be to clear all the fractions by canceling out any common denominators, or any common factors, rather. So x plus 3 cancels out, and I'm left with 2 times x plus 1. You guys okay with that?
Yes.
Okay. X plus 3 cancels the x plus 3. X plus 1 cancels the x plus 1. But I have this minus sign, and I have two terms here. So you need to be very careful on this one. When we bring down the 3x plus 5, both of them are being subtracted. So I'm going to put that in parentheses. 3x plus 5 here, because I'm going to have to distribute that negative sign. So I did cancel out my common factors, but if I have more than one term here, I need to put that in parentheses before I bring the minus sign down. So we're done with that middle term. Equals. What gets canceled out for this last term?
Plus 1.
Yeah, the x plus 1. That whole thing. So all we have left is 5 times x plus 3. And now we're the cleanup crew. Okay. The third step is to simplify or clean up, which means I need to distribute anything I can distribute and then combine like terms. So 2 times x and 2 times 1 is going to give me 2x plus 2. Then I have a negative times 3x, so that's going to be a negative 3x. And then a negative times a positive 5, that's going to give me a negative 5. Equals 5 times x and 5 times 3. That's going to give us 5x
Plus 15.
plus 15. Okay. So now cleanup crew commences. We're going to go ahead and combine like terms. So I have this 2x minus 3x. That's going to give me a negative x. Then I have a 2 and a minus 5. And that's going to give me a negative 3 is equal to 5x plus 15. And then, hopefully, I've been sort of quizzing you guys a little bit here and there of what type of equation is this. But if I don't have something with an exponent, this is just a linear equation. So I just need to get the x's on one side and the constants on the other. And it doesn't matter how you do this. I'm going to do this my preferred way, which is moving the x's to the left and then moving the constants to the right. So I will add the 3 to cancel it out, and I'll add it to the 15. Okay, so I have negative x is equal to 5x, and now this is going to be plus 18. Then I need to move the 5x by subtracting the 5x over here. Cancel that out. I now have negative 6x is equal to 18. And then the last step is to divide by negative 6. And I get x is equal to negative 3. So the fourth step is really to solve the equation. And then the fifth thing we need to do is check. Is -3 restricted?
Yes.
It is. So since this is restricted, then I'm going to throw it away and I'm going to say the answer that you're going to put in Alex is the empty set, which is just a funny way that mathematicians say that there's no solution.
So is there really a difference? Because I know sometimes it says undefined and no solution. Are those
They are different. Okay, so no solution is when there's nothing in your solution set. Okay, undefined is when you actually divide by 0. So,
0.
like, if I were to take that fake solution, essentially, right, because this is not valid, the -3, if I plugged it into the equation and I did 2 divided by -3 plus 3, then that would come out to be a problem that is undefined because it doesn't have an output. So undefined is when we can't get an output because we can't divide by 0. But throwing away that solution means that there's nothing in our solution set, so we just say there's an empty set or no solution in our solution set. They're related, but they're distinctly different, okay? Questions, comments there? Okay. So I'm going to put you guys into breakout rooms. 2 big breakout rooms, really, so that you can work on some of your homework, ask each other some questions. And I'm going to be popping in to see if you guys need any help, if you have any assistance, or if there are any questions on the homework that you guys want to like do a like screen share and then have me go over. I can definitely do that. But we're going to do that for about 15 minutes, and then we'll come back to the main session and see how we're feeling and then dismiss from there. Okay.